Hello, everyone. My name is Emin. I'm really pleased to be here. And I'd like to tell a story because I feel like sometimes we don't have enough stories in the community, focusing a lot of effort on technical talks, focusing a lot of efforts on introductions, some specific materials, but not enough stories. And specifically, stories not from the Googles and Facebooks and Apples of the world, but from companies that are very similar to what most of us do. Because when you choose a technology, you have a lot of options to choose from. You've got all sorts of frameworks, language tools, and if you look at their websites, everyone says that they're the best thing ever invented. But you really, quite often, there is a missing piece, is whether this will work for me, whether this is something we can pull off. And so what I'd like to share is a story of how we used Clojurescript and React Native to build our apps, and maybe this will help some of you to drive your technology decisions. So to start, I'll just give a quick introduction of who I am, where I come from. So right now we're here in Bulgaria. This is where we are, and it's about the same size, so small country, about 10 million population. It's a post-Soviet country. And like most post-Soviet countries, we went from having very little technology back in the 90s to a lot of technologies in the last 5-10 years, and mainly facilitated by the oil revenue. And so a lot of money is coming in country, and you will get all sorts of technologies, ubiquitous broadband internet, full coverage of 3G, now 4G, smartphone revolution, everything. And quite often what happens in those scenarios, you tend to skip over a few generations. So in fact, a lot of people skipped through desktop computers completely, went to laptops, to mobile devices, to iPads, tablets. And also a lot of people haven't even used a proper desktop app. So most people started using the internet services, and not only at work, but also at leisure. And everyone is now having their mobile device, running Facebook, running apps like Facebook, Instagram, YouTube, Google+. Okay, not this one maybe. And at some time, at the forefront of this growth, local services started to grow as well. And this is where we found ourselves at. And in our country, we run classifieds websites. And if you, depending on where you come from, you may have heard of Avito, OLX, or Craigslist. Basically, if you have used any of those websites, you will immediately recognize it's a way for you to buy and sell stuff online. And as I said, people starting adopting global apps as well as local apps. And we were going through rapid expansion, especially during the last couple of years, going through 300,000 monthly users to 1.5 million, even more now. And for a lot of for the last few years, what we also noticed, again for the same reasons, is that I think we were ahead of the global trend in terms of having more than 70% of our visitors coming from mobile. And for a long time, we've thought this is fine. We have a mobile website, we have a desktop website. Both are set up in a way to provide the most relevant experience. But at some stage, we realized that as we kind of grew to 1 million users a month, we realized that everyone expects you to have an app. People call and write to you, demand to have an app. And moreover, it leaves space for competition to come in and hit you in the weakest spot. But at the same time, we were a really small team. None of our team, no person on our team has previously built a mobile app. And once we decided that we need to get serious about this, we need to build something, we also had this technology choice. What do we do? What do we use? What do we choose for us that can help us move quickly? And naturally, because we've been doing websites up until this moment, we really wanted to have all of the same benefits, like being able to launch quick and iterate quickly, try to maintain the same code base, avoid Objective-C and Java if we can, at least as much as we can. But at the same time, we also wanted to eat cake and have it by getting an access to native features, to have a fluid experience, and all of the kind of platform-specific features that you may get. So we've started to consider our options. So what can we do with our resources, like adding or may not be adding any people to the team at all. So if you look at the landscape of the things that you can do, when you, between website and a proper native app, you've got all sorts of different hybrid versions, and depending on, there are lots of different definitions of what is hybrid, but anything that's not website or app, I would be calling a hybrid here. And obviously what we wanted to get is to go as much to the right as possible, but without actually writing any native code. So we decided to evaluate our options, so what are the things that we can do. And obviously the first thing that comes to your mind is just do a website wrapper. Just pull a WebView, add a wrapper, call it a day, and have an app in the App Store. And while it is a reasonable option, and I think we underestimated it a little bit back at the time, it does come with drawbacks. Specifically, even if you have the same service on your web app, on your mobile website, and on your app, expectations are different. So with having exactly the same experience, the perceived experience will be worse. At least that's what we found out. And besides just adding an icon on the phone screen of the customers and being able to be discovered in the App Store, you don't get much other value. But again, a lot of times, for a lot of people, it would be a good first step while you're building your app. You already start building your audience, that's kind of, you already have something in the App Store. So second option for us was kind of be somewhere in between, just do just enough of the native shell and pull in the rest of the app via WebView. And it was especially relevant for us because we use Ruby on Rails on the backend. And for those of you who are familiar, they have this tool called TurboLinks, which allows you to very quickly develop kind of sort of a hybrid app. And it's a great way of building an app, especially if you have, like, folks building Basecamp who developed this tool, hundreds of custom screens, because you don't need to re-implement all of them in your app. At the same time, it does retain some of the drawbacks of the web use, obviously, because at the end of the day, it is WebView. And when you don't have many screens and you can afford to rebuild them, there are better solutions available. At least in our case, that was what we found. So, which brings us to almost native experience. And again, even within niche, you've got React Native, Xamarin, NativeScript, lots of other tools. And even with that, within that niche, trying all of them would be spending way too much time. But with most of them, what you do get is you get to use exactly the same tools that you already love and know. And you get to share most of the code between your iOS and Android versions. And you can go and update your app without going through the App Store. So we actually, as you can guess from the title of the talk, we went through the React Native. We actually didn't get to explore other options for a few reasons. We already been using React on the web. It worked very well for us. We like the paradigm, we like the component model, we like the way kind of the data flows through the system. And it already, at the time, it was more than a year ago, had a good story both on iOS and Android and a good ecosystem. And you code in JavaScript. So let's see how we get started with doing that first. So actually getting started is pretty easy. You just run those 4 commands, assuming you've got dependencies installed, which could take a little bit more of your time. But assuming you've got dependencies installed, just these 4 commands, and in 5 minutes, you have something up and running on your device. And now this may not be much of an app, but at the same time, remember, you don't know anything yet about mobile development. You don't know Objective-C, you don't know Java, you don't know the mobile-specific development process, yet you already have something running on your device, or an emulator, depending on what you prefer. You already have something running, you can dig it, you can try and change something, and you can see the result immediately on your phone. So this is a very satisfying experience. It's actually resembled like back in the 90s when first active server pages started to appear, for those who remember, and you do a loop on the server, you generate a bunch of HTML, and voila, you've got something up and running. You're sort of a developer now. So that's how a lot of us started, I believe, and that's the thing, that's the feeling you get, right? You don't know anything yet, but you already have something up and running. But let's see what's the code behind this simple app. You've got a bunch of configuration and dependencies, as I said, but this is the essence. This is your index.js file that you receive, that you see. And yeah, you've got a couple of inputs. You've got something resembling a style sheet. And you've got your main component that renders an app. And if you notice, what we have here is view, that component that contains a text component. And this is how it works in React Native world. You use JavaScript, and if any of you tried React before, it will be very familiar. But instead of rendering to DOM, instead of having divs and other tags, you render it using to native components. It's a native view component that renders native text component. So you've got a native app in that for the customer, for the user, it is exactly the same components that they have in other apps, but you orchestrate it by using JavaScript. So you define in the language you already know how components look, how they interoperate, and any action that's kind of derives from user activities. So this is, and importantly, you use something similar to CSS to style your app, and something similar to Flexbox, or almost like a Flexbox, to do your layout. So if you know any of that, you already can kind of start doing things. And while it's kind of cool, you already have something. Also, it's JavaScript, right? And I'm not sure about you, but for us, we used to use Ruby on the back end, and every time we have to move to front end or to React Native and use JavaScript, it feels like a downgrade. JavaScript's got all of its quirks and whats and lack of standard library and all sorts of callback hell. I mean, I'm sure any of you who did a lot of development in JavaScript knows its problems. It shares problems. But obviously, this isn't limited to React Native. It's the same issue when you do a web app. And we already solved this problem on web by using Clojurescript. And now, obviously, describing why specifically Clojurescript will be a whole separate talk. But basically, kind of in a nutshell, it's just a modern language that is designed for immutability and concurrency. So if you like the previous two talks and you want to use all of those great things, you get that for free with Clojure, right? So you've got all of those persistent data structures, you've got all of the immutability, you've got everything that was talked in depth, and you get to use the modern language which got very concise and modern syntax, which got rich data structures, basically anything you would expect from a not JavaScript, right? If you want to know in detail about this, I highly recommend this talk, Clojurescript for Skeptics. It was given a couple of years ago. Even if it's now even better, the situation is now even better because some of the things mentioned as a potential problems there for newcomers have been solved since. It does a good job in convincing that it may not be as crazy choice despite the parentheses as it may seem. And even if you are on board, this may help you to convince some other people on your team. So let's see how it looks. And this is not React Native yet, this is for the web. And I'm using Reagent, which is a wrapper in Clojurescript for React. And if you notice, basically what we have is a function, defn, which returns an array or vector, an array of elements. And probably you can guess that it is a div inside which you've got a couple of paragraphs. This is how it looks like on the bottom. And the common topic is, and this is the way things are recommended to be done in Clojure world, is you've got functions operating on data structures. So basically, it's just a function that returns your data structure. Everything else of how it actually maps to the HTML, in this case to HTML happens under the hood. But for your purposes, it's just a data structure. Let's say a more involved example. So in here, we use Reagent, as I said, and it's got, and the common theme again in most apps, you've got a global state. In this case, that defines your UI. Basically, in most of the, or in any, I guess, React application, your UI, what you see on the screen is a function of your state. So in this case, state is very simple. It's just a click counter, which is initialized to 0. Then we have a component, which renders this, the atom called click count has value. It references the atom to show the actual value, 3. Well, after you click it 2 times. And the important part is here. On click, it increments the current value in the state. So what's happening is behind the scenes, any component that references or dereferences, as we call it, the state is automatically re-rendered for you as soon as its value is changed. So by updating the component, by updating the global state, we trigger the re-render and the value here gets updated. So you don't need to do anything else. So you've got your state, you've got your components. Based on the actions of users, you update the state, and those are the updates, as I say, you can have, and as shown in the previous talk, you can do a time travel by keeping the copies of the previous state. And by updating the state, you trigger the re-render of your UI. And it turns out that that's all you need to build a mobile app with React Native and Clojurescript. But before I go further, just wanted to make a comment. This may look unfamiliar, right? What's up with that parenthesis in the beginning, not in the end? You know, the usual complaint about the Lisp code. But I really want to make a note that unfamiliar doesn't mean complicated, right? It's just unfamiliar. There is a great talk by Rich Hickey, who is a creator of the Clojure, and it's not about the Clojure. I highly recommend this talk to everyone. Even if you are never going to touch Clojure, it will make you a better programmer. It explains the difference between things that are easy and things that are simple. And for instance, I guess for half of the people in this room, Bulgarian was language that you could fluently speak since you were a kid, right? And for me, I don't know any Bulgarian, right? Does it make it hard language? Does it make it an easy language? It's subjective, right? So if you want to assess whether it's simple or complex, you will have to find a different criteria than what you personally know. You have to assess, for instance, stemming rules, grammar rules, and see what is more complex and what is more simple. Same with the code. The fact that you are not used to the code that you see doesn't mean it's complicated. It just means it's different. But there are objective criteria, and Rich uses talks in this, describes in his talk what are the objective criteria that you can use to evaluate whether the language or the language constructs that you use are simple or just easy. And by that definition, Clojurescript and Clojure are very simple languages. They're designed to be simple. They're designed that all of the primitives are simple. And so it's very easy to reason about, it's very easy to work with once you become familiar. So let's see how we build an app in a Clojurescript world. And you probably would think also the same for commands, not very, but very similar. Again, you install some dependencies, you run those 4 commands, and you got an app on your device. It's a little bit more advanced app. And this was the time, at least for me personally, when I ran those 4 commands, when I felt a relief. I felt like, okay, it may not be that complicated after all. Maybe despite the fact that we're a small team, we can still pull it off. We can still build our apps within a reasonable time frame, within reasonable budget, and launch them. And as I said in the beginning, not in the beginning, in the React Native example, JavaScript example, you don't know anything yet. You haven't learned any new concept, but you have something up and running. Very important. So I dumped down that application to compare it to JavaScript version, and this is what you get. And if you remember, it's basically pretty much the same. Couple of imports, couple of definitions, style sheets, and the component. But let's see the difference. And I mentioned that in Clojurescript world and in Clojure world, we prefer to work with data structures and functions. And if in JavaScript example, the styles was a special style sheet class, in here it's just a hash or map. If approot is just a function, which again returns you just an array of 2 components, a vector, and in the same fashion, the view and text are native components, but you manipulate them, you orchestrate the whole process with Clojurescript. So let's compare that specific piece of code. In JavaScript, you've got class, which extends component, which returns, which has a render function, which returns JSX, which returns components. And here you just get a function that returns data structure, and that's it. So much fewer concepts to learn, much fewer concepts to understand, which makes for a simpler language, which makes for a simpler construct. So I don't know about you, I prefer the second option, even though the parentheses are in the beginning, but I think it looks better. So going through that process, we built a prototype. And we decided that, yes, it is doable. We can do that. So we hired one more person to the team who would work full-time on this. And in 3 months of work, including mockups, including designs, including markup, including backend API, and beta testing and everything, in 3 months we launched an app. It's got about 5,000 lines of code, no native code at all, except some configurations, which cannot be even treated as a code. And this is how it looks. Hope it plays. Yeah. So basically, you've got standard, if you like, application with sorts of scrolls, endless scroll of listings, searching and filtering, custom per category fields, photo galleries, detailed view, zooming, bookmarks, native shares, dialogues, swipe to back, ability to add your own listing. It supports 2 languages. It may be not that basic after all, clearly not a Basecamp either, but the important part is, despite the fact that it's relatively small, is how good it is. So I hope you can see that it's fast, it's fluid, it works seamlessly and in the same way, both on Android and on iOS. And if there is one takeaway that I want to kind of you to take from this talk is it is possible. It's not without its share of issues, but that's what we've been able to do in just 3 months and having no previous experience with doing this stuff. So, yeah, is it still showing? Yeah, it's still showing something. Right. And the more important part is it's not a hassle to support as well because it's, again, one application for both platforms. It's not 2 applications. We share like 99% of the code between iOS and Android. So, let's see. You may ask, if it's all that great, if it's all that fast to develop, why did it even take you 3 months to develop? In a way, you would be right. The first version of this app actually was shipped for our internal testing in just above a month. And most of the time is spent on details. And those are the details that separate just a regular app from a good app. Those are the details that if you don't take care about, your customers will not like, that your experience will not be good. So I'll share a couple of examples that, it's simple things like when you do swipe to back, when do you start to detect that it's swipe to back and not just a random touch, right? Especially on Android, which doesn't have this natively. So a couple of examples, and those are not rocket science. I think quite often what happens is engineers develop on a local machine or next to the production server, and they don't notice these problems until it actually ships, the problem ships. So what we see here on the left is a list of products, and when you click on it, it immediately opens you the detailed view. So what would you do on your regular website, right? You would fire a request, you would get a new page, and you would render it. And that would be fine, but that means customer needs to wait while the request is being sent and comes back. But if you look carefully, we already have this same name here, we already have price here, we already got a picture, we already got some other data like date, so why not show it right away? So, especially in React, where your UI is a function of your state, what you can do, you can partially populate your state. You can populate the title, you can populate the photo, you can populate some other attributes, and fire a request to the server. And by the time the full response arrives, you already have something on the screen, and then you populate the missing pieces. And many apps do that, but a lot of apps don't do that. A lot of apps, you just click and wait for the response. But you can make it even better. You can make it even better because if you look again carefully, there isn't much additional data. That's the only piece of information that you don't have here. And nothing stops you from sending that along with the full list of products. Obviously, this increases payload, but after you zip it, it's just text. It's just a few kilobytes of additional data, but the experience is much, much more fluid because you click and you instantly get the full view. You don't even have to wait for anything. We still fire a request to those things that are below default, but other than that, from the user perspective, it's just immediate. So, very simple thing, very often it's not being done. Second example is, in a way, it's similar. It's a list of categories that when you click, you get a list of subcategories. When you click, you get a list of properties that you can filter against. And again, the same problem. On a lot of apps, you click on the category and you wait until the subcategories get loaded. But if you think about it, that data changes very rarely, right? You don't need live data of your count of your listings. You don't need live data of the category. What you need instead is to load it on the very first time the user launches your app, you cache it, and then you update it in the background. So you can update as frequently as you wish. It depends on your domain. So we update once every few hours, just in case. It's just about 10-15 kilobytes data on the very first run. After that, it's always instantaneous. The users don't notice it, they don't care about it, and it updates in the background, so it's always almost up to date. And for many cases, this is what you should, by doing that, you can significantly improve user experience. So, let's see. So we developed an app. Obviously, I can't describe the full experience of building an app because I want to capture the whole process, including the backend API. So which brings us to transit format. To get data, you have to have a backend server which actually sends you data, like building an API. And you may say, okay, we've got JSON for that. And in a way, you would be right. Yes, you can use JSON. It's good. It works. But also, it's not great, right? If you ever try to pass a date or a set or a float or try to use anything else but strings as a keyword, you will know what I'm talking about. Lots of limitations that you have to work around. The spec is tiny, it's good and easy to understand, but also it's tiny, which means there are lots of things missing. So enter transit format. Just like Clojure works on top of JVM and Clojurescript works on top of Clojurescript, transit is a sort of a hosted format. It works on top of JSON or message pack if you use it for binary communication. In our case, it was JSON. And because it works on top of JSON, you can reuse all sorts of high performance parsers. For instance, that's the only option you have in the browser. And it supports any data types, many built in, but you can also have custom data types. It supports arbitrary keys, and it's language agnostic. So you can use it to, say, power your Angular app working with your Django backend, right? So it's got a bunch of official implementations, and it's got unofficial implementations in almost any language. And because you don't have any of those limitations, you don't have to work on the lowest common denominator. And again, simple example just to illustrate in our case. So we use Ruby on the backend. And if you use Ruby, you know that idiomatic Ruby uses keywords, symbols, as a keys in hash. Same in Clojure, we use keywords as a keys in the maps, called the maps. So if we were using JSON, we would have to downgrade both to use a string key, not a symbol, not a keyword. Or we would have to alternatively implement our own way of encoding the keyword and then decoding it back on the Clojure side. But because we use transit format, because it allows you to use arbitrary data types and arbitrary keywords, you get that for free. Any language which got this construct will get that for free. For those languages which don't have this construct, you get custom elements that you can use, or you may choose not to use. And the beauty of it is if we decide to change our backend to Clojure at some stage, we don't need to worry about it. Because if we had used JSON and we upgraded backend or changed backend to Clojure, we would still be ending up having to use JSON between Clojure and Clojurescript, which doesn't make much sense because you use this format that doesn't support many things despite the fact having the same language on both sides. So transit in that sense solves a lot of problems. I highly recommend using it anywhere where you use JSON. The way I like to talk about it is it's got all of the benefits of JSON without all of its drawbacks. Just a couple of additional imports, and there you go. So, which brings us to the last part of the talk, which is updates over the air. So you built an app, you created a backend, you deployed it, put it to the App Store, you showed it to the users, and then obviously what happens, reports and complaints start coming in. So you create an update and you have to wait while Apple approves your update for a few days. Now it's much better. It used to be 3 weeks. You had to wait 3 weeks to get updated. Now it's down to a couple of days. But even then, even with improved process and Google Play Store is much better, you still have to go through this complicated process, and anyone who had to submit apps to App Stores knows what I'm talking about. And in Apple case, you also lose all of your reviews because they only show you by default reviews for the last version. So because of that, what happens is developers tend to accumulate the changes and submit them like once a few months. But we don't have to do that. We don't have to do that because if you think about the website wrapper example, had we created just a simple website wrapper, every time we would update our website, our app would be up to date, right? Because it's just JavaScript and HTML and CSS just comes from the web. But here we use the same. It's again all JavaScript, right? And most updates don't require you, unless you upgrade React Native itself or you want to ask for additional permissions like sending push notification or anything. You can just update JavaScript over the air. And most updates are like that. Change a label here or there, fix some edge case, adjust the way API is being processed. Most apps are like that. You can push them over the air, and it introduces you, it speeds you up. It shortens that feedback loop. It's still not as short as on web, where it's almost immediate. As soon as you deploy, everyone gets a new version. But it's much, much faster than a typical mobile app. So we use service for that called Code Push. It's by Microsoft. And basically what you do, you just register and integrate SDK. And then you decide how you want to update. So you push an update, and then it's up to the logic of your app how to download that update. When we started, we did it in a really stupid way. We just downloaded it immediately and applied. And what happened is user would be in the middle of their workflow, say typing a very long description of their listing, and then whoa, it will reload the app. So that wasn't very good. Now we are a bit smarter about that. We download it immediately, but we apply after some period of inactivity or if the app is closed. So with that, it's almost seamless. You don't even notice that something happened, but you're already running. As long as you're using the app regularly, you will always be having the most up-to-date version. And yes, and important part is you can do selective deploys. You can roll back in case of problems. So basically, the whole distribution can be managed effectively just through your command line. And this is the actual command you use, basically just a bunch of commands to list deployments, to release your app, to see its adoption, so you can see how many people on which version. And you can roll back. So we launched it about a year ago. We launched the app, and this is the results that we were able to achieve. So we launched with the support of iOS 8 and Android 4.1 and higher. We got about 200,000 installs, and about 20% of the daily sessions right now are from the app. Apparently, app users are the more active users. We've got 99.8 crash-free sessions on both platforms. It's actually 99.9 on iOS now. The very first version was 80%. That wasn't the one we launched, it was first beta. And average rating is 4.7 for more than 3,000 reviews. So we've got very positive feedback, almost zero marketing. Anyone who can use, who uses our website has an option to download it, and it's been very good, very successful. We got a lot of positive reviews, and there is one review I couldn't resist not sharing. It was like, I didn't like the app, but I'll give you 5 stars for the effort. Now, not very often you have such a thoughtful user who thinks about the effort that you have put into building an app. It was a lot of effort indeed. So thank you, anonymous user, and thank you for listening for me today. Thank you.